people in security get attracted because there's a bit of them that's breaking things. And I think this is even the same with developers. Like developers probably as children pulled their toys apart to see how they worked. My name is Troy Hunt. I develop security software and I built a little website called Have I Been Pwned? I launched Have I Been Pwned in December 2013. Within weeks, it just took on a life of its own. One of the things I did very early on is just optimize as far as I possibly could. So everything from caching as much content as I possibly could through to obviously reducing the overhead on all the requests. So I had things like auto scale configured on the app server. CPU goes beyond a certain amount for a certain amount of time, then I'd get another instance. I'd keep sort of adding these logical units of service so it would scale, which is great. And then I had cases like a TV show in the UK ran at prime time, Have I Been Pwned on it? And my traffic just increased hundreds and hundreds of times over in the space of seconds. And I got smashed and I lost requests. I just couldn't deal with it. The thing I couldn't escape is that whilst I was constrained by autoscale and app service, and whilst I needed to see resources utilized to a certain amount more resources, I was always going to have this problem. So ultimate solution came via functions. So I've been moving a huge amount of stuff from APIs running the app service through into functions. And by running serverless, suddenly you have a scale which is not bound by any sort of logical infrastructure over the top of it. Now here's sort of the secret behind Have I Been Pwned. The objective wasn't just to build a data breach notification service, the objective was to build a data breach notification service and to play with Azure. There's a few key things that I look at the dashboard. So I want to see things like infrastructure performing. A lot less important because they just scale and perform beautifully regardless. But particularly on like my app service, how much of my CPU am I using? Am I going to need to scale into a new instance? On my SQL Azure database, I want to know how many DTUs I'm using, because if I start maxing out those DTUs, I might need to go in and scale it up myself. And even for things like functions, which scale almost endlessly, I still want to see traffic. So I want to glance, is there something with Have I Been Pwned that's just driven a massive amount of traffic to the site? See that immediately on the graph. The single best decision I made in terms of the services to use at the beginning of Have I Been Pwned was to use table storage. This is where the bulk of the guts of the data is. So there's 5.5 billion records sitting here in table storage. It's not the only storage construct I use. I use Azure as well. And in SQL Azure, what is things like data loads and notification use. The app service is the website, and then increasingly what I'm doing is I'm shifting stuff down into functions. And then when these functions are executed, functions are talking to a combination of SQL Azure, plus of course when you actually search for someone, that needs to go to table storage. And then the Redis cache is storing a bunch of things like a list of the breaches. One of the things I'm trying to do about optimizing Azure for just massive amounts of API is move as much traffic as I can the origin site in Azure and push it back towards because that keeps a lot of traffic off my origin, lets me scale more. It also means people get requests returned in a super fast way. So Cloudflare sits in front of all my Azure things between the service and the actual service running in Azure. When someone loads the home page, Cloudflare normally doesn't have to go to the app service and pull it back. Cloudflare returns it from cache right to the origin. The users then go down and they say, I would now like to do a search for my email address. It's going to go through to Cloudflare. It's going to functions, and functions is going to pull a combination of data from table storage, which is where the email address exists, and it's going to pull it from Redis in order to get a list of which the individual has appeared in, and all the metadata around it as well. So it's amazing to look at how much open source has changed, and particularly my attitude towards open source as well. Open source almost seems to be this very empowering movement that's given everyone the ability to participate in software, either as consumers or contributors. All of the work I do in there is ASP.NET projects and Azure Function projects. There are a whole bunch of supporting projects. There are console apps and things like that, great little tasks that I run. And I do all of that in Visual Studio. But I've also been using Visual Studio Code for things like managing the template for my blog. That's what I'm using to teach my son to learn how to build web pages because it's a great way for kids to learn as well. So one of the things that had always driven me since the mid-90s when I started building software for the web is it's almost this dream of I can go and build something myself, just on my spare time, and it can be something massive. It can reach millions of people. It can be out there on the web and fundamentally change the way people work or the way they check their exposure and data breaches, or it may be, but you can do it with just about nothing. And that still to this day totally amazes me.
particular regular expressions. So some of you may remember back in 2016, there was an outage at Stack Overflow, where for, I don't know, it was 20 or 30 minutes, the system was down. And Stack Overflow released a really nice post-mortem after the fact, detailing what went wrong. And what went wrong was a regression that hadn't been fully validated for its performance characteristics, getting past a particular input that basically spiked CPU on all of the front-end tier servers. So what I've done here is I've just extracted the details from that post-mortem. I've got the particular regex here and the particular input they described, which was basically 20,000 characters. And in the bad case, it was 20,000 characters and in a white space. And now on .NET Framework 4.8, .NET 6, and .NET 7 using the good input. So we have two inputs here, a good input and a bad input. Now, if we look at just the good input, we notice something really nice. .NET 6 is about 10 times faster than .NET Framework 8. .NET 7 is about, what, 15% faster than .NET 6. Yay, we're making forward progress. Now we try the bad input. And the good news is .NET 6 is still about 4 or 5 times faster than .NET Framework 4.8, and .NET 7 is more than 2x faster than .NET 6. Woohoo! You can see the downside here, or the bad news. The bad news is all numbers are like 14,000 times worse than the good input. There's this huge disparity here. And that's what this research addressed with a new option in .NET 7 that is regex option non-backtracking. This is a fully implemented engine that's able to support most, not all, regular expression constructs. But if you yourself to that subset, it has this exact same semantics as if you're using the regular backtracking engine, so you can switch back and forth. And the important thing two important things to note, actually. For the good input, it's a little bit slower than at least the .NET 6 and .NET 7 implementations. In this case, particular input is about 5x slower. So this isn't always necessarily going to give you the best performance. However, you notice that for the worst case, it is order of magnitude faster than all of the other numbers. In fact, it is exactly the same whether it's the good input or a bad input, subject to minor noise in the benchmarks. And that's the important thing with this option. You get the same semantics as with the backtracking engine, but you get consistent performance regardless of the input that's being provided. Some really exciting work in .NET 7 here. Another category of work is sort of, or of improvements is thinking about all the places that we can reuse existing functionality. As developers, we like to kind of hand roll things, but if you just take advantage of the built-in helpers for things like searching with index of, every release, when we make those operations faster, anyone who's relying on those operations themselves gets faster. And so we've done work in this to not only improve those primitivations, but also use them in as many places as we can in our own code, such that not only your code using it gets faster, but our code using it gets faster, and then your code using those indirect uses gets faster, and so on. So here's a simple example. We did some vectorization of index of for searching strings, spans. In this particular case, I've got the complete stories or works for Sherlock Holmes and I'm searching for elementary, my dear Watson. And you can see in this particular case, when I searched for elementary in .NET 6, this was taking about a second, and on .NET 7, it's taking only about 57 microseconds. So a huge improvement there. It's a 20x. Because we're doing a better job of figuring out exactly what to search for and how to vectorize that search. Similarly, for ordinal and OR case, we're also doing a better form of vectorization now, and so this also gets about four times faster. Continuing in that theme of taking advantage of these helpers, any place where you're not, it's worth reconsidering, are there workarounds that you've employed where you'd be better off just getting rid of your workaround back to the original thing. So here's an example of that. This comes from some real code, which I've simplified down. If I want to look to see whether a URL begins with HTTPS : it starts with ordinal ignore case because I don't care about whether it's capital HTTP or lowercase HTTP and so on. Now, at some point when someone wrote this code, they benchmarked this and realized that they could do it faster if they just open coded it, if they just did it themselves. So we have, they're checking the length here to make sure it's at least 8 characters. Then they're doing some really cool ASCII tricks, recognizing that the uppercase ASCII letters differ by only 1 bit from their corresponding lowercase letters. So if I just OR in 0x20, I can do a single comparison for each. And they probably benchmark this. And in fact, when I benchmark the .NET Framework 4.8, I see indeed the open code 10 times faster. Woohoo! You know, good days work. But both of the numbers have actually gotten faster. The 21 nanoseconds has dropped to 6 nanoseconds. Still better, but is it worth it? Maybe, depends on the use case. Now we go to .NET 7, and now not only is open coded version way more code to maintain, it's also twice slow as the built-in implementation, which the JIT now recognizing these patterns and is able to generate the most optimal implementation it can version of the code. Anytime you're employing these kind of workarounds where you want to revisit them and figure out whether the thing better, everyone's thinking, and anytime it gets better, everyone's code gets better. And speaking of getting better, another important lesson is no matter how optimized, there's always more opportunity. There are always new things you haven't explored, maybe improvements elsewhere in the system that you previously dismissed because they're too slow, but now they're actually highly optimized and you can take significant advantage of them. And a great example of that, again, comes from regular expressions. So this particular benchmark isn't actually one that I came up from an open source repo that's comparing the performance of regular expressions across a whole bunch of languages and frameworks. I just copied that expression as well as the input that repo is using. And I'm counting how many times an email address, which this expression is meant to find, occurs in this input text. And if I run this on a variety of previous releases of .NET, we can see on .NET Framework 4 taking about a second. You go to .NET Core 3.1, it improves by about 10%. That's pretty nice. You go to .NET 6, and oh man, it gets what, about 20x faster at about 49 milliseconds. And then you go to .NET 7, and it gets even orders of magnitude faster at about 620 microseconds. But then there's even more opportunity. So one of the things we've done in .NET 7 is introduce a bunch of methods onto regex for doing specific operations like counting, which is what I want to do here, or enumeration without actually allocating, sort of amortized, non-allocated matching with regexes, as well as be able to pass in spans that I can slice or get from wherever it may be. Maybe I stack allocated some memory, or maybe I got some data from native code. I no longer have to copy it into a string to search it. I can just send directly into the regex engine. And now when I just change the code to use the simpler code, it's also faster. It got about 20 microseconds faster. You'll notice that lovely allocated column is blank. That's because there was nothing allocated as operation. So there is always more opportunity. And then finally, one last category to think about, and there are many more than this covered in the paper, but one more for this presentation, is being thoughtful about your defaults. And we strive when we design APIs, when we design language features, we try really hard to come up with good defaults, where if someone uses something, they're going to get kind of really great average case performance out of the box. We don't always get it right, and I imagine you don't always get it right either. We're thinking about those defaults both for new things and revisiting previous choices. And an example where we revisit a previous choice in .NET 7 is compression, and specifically with Brotli compression. Brotli is a compression algorithm from Google. We've been shipping an engine, a Brotli stream type and Brotli encoder in .NET since I believe .NET Core 2 or 2.1, around there. And if you have the Brotli compression algorithm, like many compression algorithms, it has a knob you can turn, a dial. In Brotli's case, it goes from 0 to 11. And on one end of the dial, you have really fast compression, but maybe not the best compression ratio. So maybe you end up with a larger output. And at the other end of the spectrum, you have the possible file size or output size it can muster, but it might take a really long time for it to figure out how to optimally. Now we can see I bent both size and time, particular file in this case, and we see from 0 to 11 a nice sort of linear progression. Excuse me. As I turned up that dial, going from about 2.5 megabytes down to about best compression ratio down to about 1.7 megabytes. But we see not so nice a linear scale. In fact, towards the upper end, it starts looking extremely exponential. Now, the problem is that in prior to .NET 7, we chose the default of 11. Which meant so significantly performance impacting changes from 11 down to something more in the middle, around 4. Now, this does mean that by default, your output sizes might be a bit larger. In fact, if I run a simple benchmark, we can see that particular input, the resulting output is about 20% larger than previous. Now, all you have to do is set a compression level and you can get exactly back to what it was before. So we're just changing the default. But in exchange for that 20% increase in size, we have about a 50 or about 50, 75, I don't know, I can't do math off the top of my head, somewhere between 50 and 100 X improvement. And we think this is a much better use of your time when using broadly as part of your algorithm. So that was just a really, really quick tour through just the tip of the iceberg. If you have a few moments or hours, I'd welcome you to go read that the blog post on .NET 7 performance improvements. I'd welcome feedback. I'd love for you to actually get involved and contribute to the next incarnation of that paper by contributing pull requests to .NET 8, which we've already started working on, and which is going to be an amazing release a year from now. So thank you very much. Back to you, Richard.
Thank you so much, Stephen. You blow my mind as always. I can't believe the ongoing performance improvements we continue to see from C#, and you got some great questions coming in from Twitter. I'm going to start with this one here for Menham. Let's dive deeper because he doesn't know we're already feeling like we're at the bottom of the ocean. Okay, not a question, but boy, oh boy, he's not wrong. He had another question, which I thought was a little more technical here. Same fellow. Aren't there's this type of loop optimization in .NET 7, which Stephen's talking about, involves some logical bugs?
To my knowledge, there are no cases where we introduce bugs. If there are, that would be a bug that we should fix.
Yeah, I would presume so. And you always have a test suite for all of that, is right? Whenever you do an optimization, you match behavior exactly in the new in the optimized version.
Yeah, every PR we run a pull request. We run about 8 million tests across multitude of operating systems and versions of operating systems and so on. Plus, then kind of not as part of PRs, additional set on a rolling basis on a huge number of platforms. Now, there are always gaps. There's always the possibility that we'll introduce bugs, but we have a very, very large test suite in order to try to choose. Some slip through. That's why we have servicing, where every month we will ship bug fixes for things that are either brand new in that release or maybe that have been latent for many, many years and are only just noticed. But if you do find a bug in how the JIT is compiling loops, we would love to know about it. So please shoot in .NET Runtime repo.
Yeah, so GitHub's there for a purpose, right? We'll be able to put the issues in directly to you and see them directly addressed back again. Hey, let me give you a little more philosophical question as well, which is, why didn't you optimize this stuff in the first place?
That's a great question. I mean, we strive to optimize things in the first place. In some cases, there are opportunities where we just didn't notice them. Maybe we got smarter or we learned from other people. For example, the index of case, we're actually taking advantage of a really nice algorithm that was designed by someone outside of Microsoft that's become really popular on various frameworks and languages in recent years. We're building on the shoulders of giants, taking advantage of somebody else's work there. In other cases, we're able to build on our own shoulders. Work that we've done in improve sort of lower things or add new lower level constructs that we elsewhere in the libraries. For example, we did a lot of work in .NET Core 3.0 and .NET 5 to add literally tons of new methods that represent direct hardware instructions for doing sim. And then in .NET 7, we added new Vector 128 and Vector 256 APIs for at a higher level for taking advantage of all of those hardware instructions across platforms. And anytime we add those kinds of intrinsics or helpers, we can then go and take better and better and more advantage of them elsewhere in the platform, finding more and more opportunities to sort of leverage those underlying performance benefits. In other cases, it's research. I mentioned all the stuff coming from MSR or from other companies or from academia. There's always more opportunity, and as much as we get it quote right the first time, invariably there's always more to do.
Really appreciate your point that computer science research continues to go on, and MSR bringing you things and moving that hardware underneath you so that you now have to take advantage of it. But I get that too. I was also thinking that sometimes your customer in a way you've never thought of, and it introduces a new optimization opportunity.
And in fact, many of the performance improvements that come from outside, things where we just weren't looking at it. Someone else had they were using some code path weren't focused on, and it ended up being a bottleneck. For the beauty of open source is they can come in and can fix to something we may not have touched or may not have reviewed, and they can improve it not only for themselves but for everyone else that happens across that code path in .NET.
Wow, I can't imagine trying to do my own optimization base. That's stunning to me. But I guess it's a possibility. Does it happen very often?
It's actually pretty common. About 20% improvements that I sort of documented in my paper came from outside of our team. And a lot of times it's removing an allocator or finding that some code here could have a fast path that's common, or there are certainly some of the more intricate. Someone going in and actually adding an optimization to the JIT. Those are more generally, but there's a wide spectrum, and we love them all.
Stephen, I'm wowed as usual. Thank you so much for your contribution to .NET. I love that Mike faster with each new version, and we've got to move on to the next subjects, but make sure you do your survey. Links below me here. We need that feedback to know exactly. And don't forget our great sponsors. They've put together some awesome swag bags. And if you do the secret decoder, tomorrow we'll be doing a draw. Now it's time for me to hand over to Jared Parsons, talking a little bit about how language features actually get built. So if you wanted to understand how the plumbing works, we're talking to the right guy. And I'll talk to you afterwards.
All right, hey everyone, my name's Jared Parsons. I'm the C# compiler dev lead as well as a member of the C# language design team. And here we're here today to talk about let's design a language feature. And what we want to do in this session is kind of pull back the curtain a little bit and show you kind of how the language design process works. How do we start from a problem and an idea and get through all the tools to a shipping feature that we deliver as a part of the .NET and C# releases. And what we're in this session is we're going to be using an example of a feature we shipped in C# 11 to kind of take the process, and that is file local types. Now, all ideas start with a problem. And in this particular case, the problem came from our source generators teams. Now, for those of you who are unfamiliar, source generators are a way that the library plug into the compilation process. They can look at the code you're writing and use it to generate code to augment your application. They can add new functionality, can add optimizations by moving stuff that used to be done at runtime into the compile time part of the process. And we're shipping a lot of generators with .NET 7. We have like the JSON generator, the library interop generator, and like what we're going to be looking at here today is the regex generator. Now, what the regex generator does is normally when you regular expression in .NET, at runtime, that expression has to be parsed. They have to generate all the code to do the matching at runtime. That can impact things like it can limit your optimization opportunities. But now in .NET 7, we to, at compile time, do all of that work. And you can see here that I have this nice little partial method called get email regex. I have this attribute generate, which tells the regex generator, hey, here's a regex that I want you to process at compile time. A nice little go to definition here. And we can look at what this generator is doing. It's taking that, it's processing it, and it's generating all this beautiful code here, nicely commented, that's actually processing that regex. And it did that all at compile time instead of at runtime. Significant performance wins for our applications. The regex, the generator authors came to us because they found a bit of a problem with this approach. Because in order to do a lot of their generation, they have to generate these helper types, like you'll see here, this derivation of regex, get email regex 0. And they said, this is a bit of a problem. We really want these types of implementation details of our generators. We don't want users depending on them because this is something we want to evolve over time, making these scenarios better. But unfortunately, it's a part of the compilation, and users can see it. Off is that when users are typing, IntelliSense actually shows it to them. It starts leading them down that, telling them, hey, this is a type that you should use. Look at all these cool type dependencies on them. And this is something they worried would inhibit their ability to evolve these generators in the future. And also, another problem. What happens if the user defines the exact same name type that they want to generate in their code? Well, that means that their generated code stops working. And in order to solve this problem, they have to complicate their generation process, have to start scanning the compilation, looking for any types of that name, and making sure they don't have conflicts. And overall, they felt like that this made the generator scenario a bit more fragile, a bit more incomplete. And they were looking to solve it. But they also had an idea. They came to us and said, listen, why don't you let us write private in front of these top level? And the effect we would have there is make that type local to this file. It doesn't conflict with types and other files that other people can't see it. And this is where kind of we have a problem. Presentation was going to talk. This is just one word really lead to the design is the text that we have to look at. And one of the first questions we start asking ourselves is this word going to stand? For example, right now, the idea is just how can we type to a file, but a lot of the way you could extend this feature in the future is making it and properties and making them to a file. In private, it's not going to work. The next thing we talked about is take two existing modifiers, slam them together, and let's create a new one. Use private internal. And this may seem silly, but this is something we've done before. A few releases ago, protected to express a new form of access sharp, and it was a very successful feature. But it is a bit wordy. It doesn't really ring trying to get here. It doesn't really scream to a file. So the next thing we talked about is maybe we just use modify private. We say, hey, private was a good idea, but let's give it a little more meaning by saying file private. And this is going to resonate with customers. This reads really, really well, and people are going to kind of get an intuitive understanding of this by looking at it. It's also a bit wordy, though. It is using two words. We felt like one word might be enough. And so eventually we kind of said, let's just use file. File is nice, it's descriptive, it's simple, and it's extend to other scenarios in the future should we want it to. And after a lot of discussion, this is where we came out with. This resonated the most with the language design team, the generator authors, as well as the various community members we talked to. And I've made this process a little bit silly, talking about the ways we deal with words, but the look and feel of C# is incredibly important. And we spend a lot of time talking about it, rat-holing, and going back and forth on the ideas. And we spend a significant amount of time on even little tiny problems like this. But the next thing we do, and we did in this case, is we said, hey, have any other languages done this before? Because if other languages have solved this problem, we can look to them for inspiration. We can see what went well with their implementation. How do customers use this feature in their ecosystem, and what can we learn from to make our feature better? And when we looked around, we found lots of examples of languages that do this. For example, F# has the concept of and implementation files. Very, very similar to header files in C++. But they have this really nice property. Only things that exist in the signature file are visible to other parts of the program. If you have a type that is only in a file, it is limited to file. It's almost exactly built here. It has more ceremony involved, but it has the basic properties we're going for. And this is a very successful feature in F#. It's used in lots of programs to wild. We look at like Golang. Golang has a similar concept.
Така, мисля, че може да започнем. Добре дошли, макар че може би повечето хора са онлайн. Това е ивента, който ние организираме като пост-ивент на .NET Conf. И аз съм поканил Ради Атанассов, който е дългогодишните контрибютори в нашото комюнити, в технологиите на Microsoft, и Иван Влаевски, който също е един от дългогодишните контрибютори с много сериозен опит в различни технологии, но също така и в Microsoft технологии. И двамата са с, може би, поне 20 години. Иван, аз го знам от повече от 20 години, нали? Като човек, който се занимава с технологии, свързани с това, което развива Microsoft. Ради Атанасов може би е по-добре сам да се представи. Той беше един от примерите за човек от нашето комюнити, който се е развил в областта на, сега се нарича Modern Workspace, SharePoint, и е признат лектор на много конференции.
Мерси, Михаил. Повече от това няма да се представям.
И аз не знам, може би, Иване, ти може да кажеш също някакви неща, понеже ти правиш толкова работи, че мен ми е трудно да ги за малко време.
Да, за всички тия години минах през почти всичко, което Microsoft пускаше, и изпробвах всички нови неща. Сега наистина ми е интересно какво ще излезе от .NET 7.
Така, сега точно е момента да коментираме, понеже конференцията започна вчера, продължава днеска, само част от лекциите са публикувани от първия ден. Има анонси с новостите, но все още не всичко е налично като видеоматериал. И основният фокус е върху перформанс, върху подобрената производителност, която ние очакваме в различните видове приложения около .NET. Реално. Така, в контекста на това, може би е хубаво да започнем с това какво вие мислите като най-интересно в точно този обхват. Където имаме ние подобрение на производителността, няма значение дали е свързано с веб приложения или някакви по-генерални други оптимизации. Ради?
Добре. Къде е най-интересно?
Да, според теб.
От перформанс гледна точка, наистина слайдовете още от първите часове на конференцията бяха много динамични, с хикс пъти повишения. Сега най-интересното е, може би, трудно да кажа. Това, което може би за мен и за работа вършиме, е нещата, свързани около System Text, JSON, подобренията, десервизирането, както и довеждането на полиморфични типове по време на сериализация и десервизация. Това е нещо, което в наши проекти и наши колеги са правили сами.
Колко да обясниш на хората, понеже от тези, които ни слушат онлайн, може и някой да не знаят точно, нали?
Значи, полиморфични обекти са такива обекти, които имат различни притежания. Съответно да се сериализира и десериализира, традиционно ние трябва да дадем твърд тип на които обръщат класове и от класове към JSON. И съответно полиморфични означава, че може да си моделираме типовете, както са в бизнес логиката ни, и да ги изпращаме в JSON формат чрез дискриминатори, евентуално да детерминираме към какъв твърд тип може да обърнем съответния JSON обект, защото той обикновено не си казва към какъв тип искаме да го сериализираме и трябва да посочваме този начин. Често в практиката се случва да направим един клас с 20 пропъртите, от които да ползваме само 6. И да имаме абсолютно ненужни операции по време на това нещо. В нашата работа това е приложимо и факта, че го има в .NET 7, означава, че сега трябва да махнем една комара код, който прави нещо и да използваме native feature.
Това е интересно, наистина. Иване, ти какво мислиш?
Аз се впечатлих от перформанс ускорен за линк. Ставаше дума за 45 висока скорост. Много се зачудих, защото то принципно малко се различаваше от това сам да си напишеш кода. И 45 пъти означава, че са постигнали скорост, която е по-висока от това, което може да си напишеш като работа. Оказва се, че всъщност това, което са имплементирали, са хардуер модели, които, разбира се, са активни само когато съответната среда позволява. Но според това, което представиха, имат и доста подобрения за ARM машините, което прави доста интересно вече на работата в тази посока.
Това е възможно, защото сега не беше и възможно да чест support и Visual Studio сега вече.
Точно така. Реално това беше доста специфично, че когато използваме разни ламда изрази, перформансът не беше впечатляващ. И сега нещата се получават доста по-добре, но реално ще видим в проекти, които са в продъкшен, понеже до сега нещата бяха в превю. Повечето компании не искат да избързват с имплементация в релиз на фреймворките, които са още в превю. Аз не знам от хората, които са тук при нас, дали искате да дадете някакъв дар по отношение на нещата, които почнаха да се публикуват около новия NET 7 и другите подобрения, ако кажем.
Съвсем коментар.
Чакаме.
От NET 5 на сайт на Hardware Intrinsics, две версии чакахме да ускорят мисъл, позабавяха се. И то сериозно, мисъл, 2 години. Тия ускорения са хубави на теория. Ще видим на практика как се случва. В смисъл, са perfect approach, дори не са истинско ускорение. Много голяма част от всичките фичери, които са обявени за NET 7 са симпатични шубер върху нещата.
Така.
Те си на...
Да, те хубаво в смисъл, хубаво ме се гледа, стигам толкова късняваше за колко перформанс имат Regular Expression. Кой се занимава с перформанс и колко Regular Expression? Мисъл, там е много гол за всеки, който иска перформанс. Давам пример веднага. В Stack Overflow да си направиха собствен парсър за да по-пригеда Remix. Да се късняха, в смисъл. И всички чакаме, в смисъл всички чакаме от 2 години, чакаме юнион типове, грид трейдове, някакви такива обещания на себе. Получаваме само много килови. И вече не знам, 60. В това отношение,
нека да го сравним също така с някои други фреймворци, където по-трудно се правят изменения съответно в стандартите. Въпреки че Microsoft е основен контрибютор, все пак те направиха много по-достъпен контрибюшън. Сега нали не е всичко черна кутия. И от тази гледна точка нещата малко
така е, но те пак убиват примерно. Там примерно че Microsoft JSON вместо да си четат, те си го взеха в Microsoft, направо си го синувиха там. Зачетнаха го и смисъл един open source проект, просто умря, защото е държавна версия. System Text JSON, който на всичко отгоре в първите си версии даже не беше по-тотален. В смисъл не беше съвместим, в смисъл нямаше достатъчно фичери в сравнение с Microsoft JSON.
И различни дефолти.
И различни, да, в смисъл беше това мазак. Малко съм Ама заслужава това пъти. Трябва да го видим.
Да. Нищо, бъдещето е светло.
Бъдещето е зелено. Чакаме.
Добре, а какво мислите за нещата, които правят с Blazor и сега има хибридно приложение с Blazor?
И малко е мъртво родено, примерно. Мисъл, те го направиха, не знам, екипа е поредния Windows Mobile, които са 14 човека и се научат да направят нещо, да цел след да ползвам, а всъщност не стига бюджета. Виждам, че сега вече след 7 версия, след като го пускаха някакъв и си има някакъв ентусиазъм, виждам, че са позасилили малко, вече му добавят техници контрол, защото това с контролки по този бизнес в момента вече контролки не съществуват, JavaScript фреймворците вече са космически, използват технологии, не технологии, използват ноу-хау, което не е рационално, нещо, което има да догоним с Blazor. Че Flutter е точно като трябваше да е малко. Всичко правим с C-Sharp и C-Sharp е супер и ще направим UI с C-Sharp и не се получи. Но ние ще направим само юзер интерфейс да бъде с дата и дата за нищо друго не мога да го ползвам и въпреки това е веб. Няма обяснение за това. Сега това няма обяснение.
Мислите ли, че причина за успеха на една технология е само техническото решение или може би са доста комплексни неща?
Всичко е важно. Значи, преди много години сън направиха Java и направиха популярна с маркетинговите 9 милиарда. За това имаме Java сега. Искаш да
Да, това имах предвид, че някои неща като решения може би са били правилни технически, а дали комюнитито приема тези неща, дали компаниите и бизнеса приемат тези неща е нещо, което зависи от много други фактори.
Абсолютно. Microsoft страдат с това отношение. То много. Аз съм сигурен с много хора, които кажат, че някакъв ми писнало, сега като напише на колко ще бъде. Се нарича неща, писали сме на всички такова, перформанс е ниво от езика, перформанс е ниво от хората. Дълго време език беше вързан с една система и всички избягаха към една друга. Всички, които сега в момента е пълно с PhD-та, професори, които са добри на Java, не е по-добра.
Така, приемам като коментар.
Като нарасне, то обикновено натрупва и негативен баланс към него.
Затова Python, Swift, те просто казват, зачекваме напред. Чакаме сега с нетърпение да видим Microsoft дали ще зачакаме, ще направят.
Да видим нещата, да ви хареса. Разбрахме, нали, някои неща.
Супер е, смисъл супер е. Просто сега тая версия по-скоро си чува да правят нещата. Предната версия беше много по-впечатляваща като фичър се.
Да, миналата година гледнаха много нови функционалност, фокус е върху перформанс. И това, и да се, и как да кажа, максимизира качество, да се фикснат някакви неща и така нататък.
Малко и тръпно много сега в 7. Много тръпно.
Разлика от 6.
От 6 до 7 много тръпно. Това са големите. Blazor също има много добър. Аз бъде чисто минимални апите там.
За Blazor е тъкнато чакане да го служат мултитрейдинг. Тогава ще бъде истинско предимство да пишеш на Blazor пред това да просто хора, които познавам, които пишат, не са свикнали да стават.
Да, с alerts.
Да, пещерна система.
А Microsoft развива няколко мултиплатформени фреймворка. Кой вие така бихте нарочили като най-интересен? Понеже Мауи е единия, нали?
В сравнение с всичко останало, ASP-то е единството, което мисля, че модерът, в смисъл, поне според мен. Никой вече не прави. Хората се отказаха да пишат мобилни приложения, отказаха да се пишат тези приложения. Microsoft се пишат приложенията направо на Teams, web приложения на практика. Така че ASP-то остава. Те за това вече е на толкова мисъл. ASP-то е нещо, което движи друго. Да, ще видим. И се учим да прави всичко. Защото наистина може да прави всичко.
Едно друго видео, което е свързано с един друг, пак така мултиплатформен фреймворк. Не знам дали сте го видели, но предлагам да направим едно превключване за малко, да видите това нещо.
Joining me here today. In this session, we're going to have a look at why a growing number of businesses and developers are picking Avalonia UI as their preferred cross-platform technology when building apps with .NET. So I have to consider that the session title is a little clickbaity. However, if you disagree or you agree, I do hope that you'll stick around to discover why I think that Avalonia genuinely is the best .NET framework for building platform applications. So let's start from the very basics. what is Avalonia UI? Well, it's a cross-platform UI framework that enables developers to build apps for Windows, macOS, Linux, iOS, Android, and the web using C# and XAML, all from a single .NET standard library. So one project, all of those platforms. And it's been developed for almost a decade with contributors from all over the globe. And it's part of the .NET Foundation, in fact, the third most active project within the .NET Foundation. So it's pretty popular and it's been around for a while. Now, you may not have heard of it, but you may know of other technologies that sound similar, like .NET MAUI or Xamarin Forms. And you're wondering, well, how is Avalonia UI different? And that's a great question. So we're different because we enable developers to build pixel-perfect apps and support the broadest of platforms by not depending on or abstracting the underlying operating system UI toolkit. So I think this is best explained if we have a look at the general architecture of Avalonia UI. So if we look at the bottom, you'll see the iRendering platform, and connected to this we have Direct2D and Skier. Now this is how we push pixels to the screen. So we're predominantly using Skier. You can use Direct2D, but most of our developers aren't. So we use Skier to draw the contents of your application. So we can create pixel-perfect apps that we only have to write once, and they're going to look the same across all of the devices that we support. And we're in good company with this approach because this is the same approach that's used by other popular UI frameworks like Flutter. And it allows us to develop a product because we're not having to rewrite that control or custom controls for each platform using platform-specific APIs. We write it once and it works the same everywhere. It also allows us to reduce support costs because we don't need to write documentation that's unique to every platform where things look different, or centers don't need multiple different scripts depending on what platform the user is using. We can deliver a consistent user experience regardless of the... So in terms of how our apps look, we have complete control over that. By default, controls within Avalonia don't have any styles. You have to add a theme in order to get the controls to look like anything. So we call these lookless controls. We ship themes within Avalonia. So the most popular one to use is the Fluent Design inspired theme, which is perfect for creating modern looking desktop applications for Windows. But there's also themes from our community, including the Material Design inspired theme, which is perfect for if you want to create an Android, for example. So we're different in the sense that everything on the screen is rendered by Avalonia. There's no native UI controls. Where else are we different? Well, less so of a differentiator with MAUI or Xamarin Forms, which is also designed to be cross-platform. There are technologies out there that are similar, that allow you to run .NET code across a number of platforms, but the API isn't designed to be cross-platform. Decided very early when we were building Avalonia that all of the APIs and all of the features that we add need to make text of a cross-platform UI framework. We're heavily inspired by WPF, but we're not copying WPF, because to copy WPF or WinUI for that matter doesn't really make sense when you think about the broad range of platforms that we want to support. It doesn't make sense to use WinUI APIs in a web browser or on an iPhone. If we took this approach, we would effectively be playing catch up to what the folks in Redmond are creating. We'd lose control over the project and what APIs we could implement. And when those features that Redmond implement make sense for the supported platforms, we would be forced into a situation where we need to throw thousands of not implemented exceptions. And that's just going to deliver a terrible experience for everyone. So we design our APIs from the initial concept through to delivery to be cross-platform. How else are we different? Well, we're really lightweight. You saw the overview of the architecture and all the little individual bits of the puzzle. There's not much to it. We just have one implementation that works the same across all of the platforms. There aren't too many moving parts, and we're very lightweight. I think one of the areas that you can see this, just how lightweight we are, is assembly and Linux. So we'll start with WebAssembly. Now this is a little sample app that we've been working on to show off XAML in the browser. So this is the full .NET 7 runtime and Avalonia with no trimming. So we haven't tried to reduce the size of this. It comes in at 7.6 megs. So it's not small, well, it's not tiny, but it's not massive either. And it allows us to write C# and XAML in the browser and see that live. So why don't I show you that to you? So here I am in my browser. I'm going to head over to avaloniaui.net. I'm going to hover over developers, down to WASM Playground. And this app works the same no matter what platform we're on. It hasn't been built specifically for the browser. This works, and it's the same code that runs on the desktop or on an iPad. We have the ability to edit our XAML here. We can toggle controls. We can load local XAML files, save snippets. We can bring in snippets from GitHub. And we can explore different controls. So let's do a combo box. Sliders. As I say, none of this is unique for the browser, it just is running in the browser. And that's what I like about this approach, is that I'm not having to customize my application to get it running on all of these different platforms. And one little cool thing of this is that we have code, but we also have some code behind. So this is why we've got the full .NET runtime in there as well. So let's call it you click me, and then when I click, you clicked me. And if I switch back to XAML, I can change some of these properties. Background equals red, foreground equals white. You see that live update. So this is pretty neat, and this is just under 8 megs .NET 7 runtime live in the browser. So if you want to try out Avalonia UI, this is a pretty great way to just explore it and get started. On the other end of the spectrum, where we did actually want to kind of shrink things down and make the app as small as possible, we have the calculator demo, which is available at calc.xaml.live. And it comes in at 3.6 megs. Now, there is an additional 0.5 megs that we could strip away to make this really lean. We would need to remove some unused bits of libskia to do that. But we thought that 3.6 megs is pretty good. We're happy with that, especially when we look at competing .NET cross-platform tech that has a calculator demo that comes in at a whopping 11.4 megs, which is 3 times as large. In fact, it's larger than our full playground. So 3.6 megs we're very happy with. And building apps for the web size really does matter. We want our binaries to be as small as possible. So we're pretty pleased with this. With the theme of lightweight, let's have a look at Linux. So if we come back to the architecture, you'll see that our Linux support only relies on X11. So we don't have any dependency on GDK. And this means that we don't need to install a full desktop environment to run your apps on Linux, which makes Avalonia UI perfect building applications for embedded situations. It's a really lightweight approach. In fact, we can get away with just installing the Linux kernel and then outputting via the frame buffer. It really is low level and very minimal installations. There's not any bloat to run your Avalonia app, making it perfect for low-powered embedded devices. Now I have a video here one of our community members sent in. Now, obviously it's not a low-powered device, but I want to show you just how fast the Linux apps are to launch. Here's the app to launch, and there we go. It's already and available to use. It's pretty fast. We've got a huge community of developers built for embedded. These are a couple of pictures of the projects that they're working on. If you're interested in development with Avalonia, there's a Telegram chat that I highly recommend you join, because there's a lot of conversation about different boards that are good to be using and advice for getting things configured. And lastly, on the subject of Linux, I want to show you a neat little project that one of our community members is working on, which is he's integrated a Raspberry Pi with a Macintosh Classic, and this is him actually building his Avalonia app on the Pi that's inside the old Mac. So this is incredible. I absolutely love what he's doing here, and I hope he shares more of this. I've seen some examples of Avalonia UI being used there, but who else is using it and what are they building? So here's a collection of logos from businesses that are currently developing apps or shipped apps with Avalonia, and we'll take a look at a couple of these. So let's start with JetBrains. So JetBrains have been bringing some of their WPF apps over to Avalonia in order to support more platforms. So .memory is an example of that, where .memory is now integrated into Rider, and those views are Avalonia. So Avalonia is embedded within JetBrains Rider. And this is pretty common. What we see is a lot of established businesses got these WPF projects, and they're looking at ways to modernize them and support a broader range of platforms. And Avalonia UI excels at this. Here's another project. This is Genie by Grit World. It's a digital engine for filmmakers with a fully customizable rendering pipeline. It's a pretty complex application. And then another example app, and this started off as a WPF app that was ported to Avalonia, is Lunacy by Icons 8. So this is now available to run on Windows, Mac OS, and Linux. They were able to reuse a huge amount of their existing code when they were targeting these new platforms. And it's absolutely gorgeous. It's a free app, so you can download that from Icons 8. So you've seen what some of the apps look like, but what does the development experience look like? Well, if you've ever built with XAML, be it WPF, WinUI, or Xamarin Forms, or Maui, you're already an expert in Avalonia. It works the same way that building a WPF or WinUI app does. You have your tools, Visual Studio or Rider, and you write some XAML and some C#. Now, we do ship some extensions. So we have extensions for video and Rider that give you a live previewer of the XAML. So on the left-hand side, you can be writing XAML. On the right-hand side, you see the change and writing those snippets and changing and making modifications. We also have, not sure when, but coming soon, extensions for Visual Studio Code and Visual Studio Mac. The idea is that you should bring your favorite tools and we will meet you where you are. Now I want to show you what the development experience is like. I'm going to go over to Parallels, and this is Windows ARM with Visual Studio on ARM, so it's approved. But I have the Avalonia extension installed here, and I'm going to go ahead and create a new MVVM project, and I'll call it hello.NET Conf. And it's created the solution for me in the project. And inside of here, I have view models and I have my views. Pretty basic stuff if you've ever done the MVVM development before. Build the project. And then if I pop over to the XAML snippet for the main window, once we've built, the designer should load for us, or the previewer, I should say. There we go. Welcome to Avalonia. And that is coming from this greeting binding here. Let me format this XAML, which comes from the data context for this window, which is this main window view model. So if we come over to the main window view model, we can see the text is here. We're inheriting from view model base. Let's navigate to there, and that's inheriting from object, which we can see is what's implementing the iProperty changed interface. Now, I happen to prefer to use the community toolkit because I'm terrible at programming. I just don't think I'm clever enough to understand that model. So let's do community toolkit. Where are we? There it is. That puppy there. Now I'm going to pop back to the view model base. Let's get rid of that. Change that to observable object. Perfect. Now I need to come into here. I'm going to get rid of this. We can get rid of this. And there is a small bug with Avalonia running on ARM for Windows, just for Windows, which I need to just do a quick workaround for. There we go. Equals false. Boom. You won't need to do that. We're going to fix that with the next version. But it's just a problem with Windows on ARM at the moment. So now that I've done that, we should be able to rebuild this. Oh yeah, that's already built. That was super quick. I'm going to do partial, and we're going to remove this. Do private string. We'll call it title, and we got the observable property. Hit build so that the source generators can do their thing. Main window view model, so we'll add the constructor. And here we can now do title equals hello.net conf. So that's just, I mean, this is vanilla community toolkit MVVM stuff, but I just wanted to show that this all just works how you would expect it to. So there we go, hello.net conf. And I can run this. There we go. Lovely. So it's inspired by, but not a clone of, WPF. So I want to show you some snippets that make this really, really obvious just how similar we are. This is a snippet of XAML that defines a window with a button in it. To make this an Avalonia snippet, all we need to change is the XAML namespace, and now it's available to use in Avalonia. There it is, and I think the biggest difference is relating to styles. Our styles kind of take an approach of a mix of CSS and UWP and so I would recommend, if you have experience with other technologies, XAML technologies, come on over to AdDoc. All of the information you need to be able to get started, and it goes quite in depth. If you have built WPF apps and you're wanting to kind of get to the point of what are the key differences, scroll to the bottom of the list on the left, and there is a whole section dedicated for explaining the key differences and tips for WPF developers. So let's have a look at the The biggest new thing is Avalonia version 11. Now, why version 11? If we look at the previous version or the current stable version, it's 0.10.18. And this zero-based versioning scheme, it led to some doubt from developers about the maturity and stability of the framework. They were kind of dismissive of Avalonia because it hadn't even reached version 1. But truth be told, it's been developed for almost a decade by those 100 contributors. It's used in Fortune 500. It's tried and tested. It's a mature and stable framework, and the zero versioning scheme didn't reflect the reality of the stability. So we decided with the next version, which is version 11, that we would adjust numbering the framework in order to reflect fairer on the reality of its stability. So we are now jumping from 0.10 to 11. So we're dialing it up to 11 as something. And we actually created a little video to demonstrate some of the features and to announce the early previews. So that was the announcement video for V11. V11 is packed full of new features. So we have the new compositional renderer, which is a huge, huge achievement for us. I'm not sure why that's a big deal. I highly recommend reading the documentation, the WinUI compositional renderer, and why that's such a vast improvement over the rendering of a WPF app, for example. We have rich text editing, upload templates. We have the new platforms with iOS, Android, web. We have Wayland support coming. The apps are faster. The binary sizes are smaller. There's less allocations, which improves collections because there's fewer collections required. It's packed full of so many new features. And one of the community members, in fact, the guy that created the Mac that's running with a Raspberry Pi, he created a little demo app in just an afternoon to demonstrate just how buttery smooth the new compositional renderer is. So you can see some of the animations here. And hopefully we'll release this as open source so that you can download this and check out the code. Now what we have to download as for V11 right now is our Wordalonia demo app. And this is like Word, but running across all of the different platforms that we support. So here's a little demo of that. So this is in the browser, and it's 100% same code across all of these platforms. So this is desktop Mac, this is iPhone, and then lastly we've got Android there. So you can grab that from our GitHub today and start playing with it and exploring version 11. There's preview 3 out already, so do check out. What else do we have? Well, we have something I'm very excited to share with you today. This may come as a
Така, и вече с лайф отново с последните неща, които бих искал да коментираме, поне за днеска в този кратък стриминг. И това, което исках да ви помоля да споделите кои са функционалностите, които очакваме. Тук имаме присъединил се към нас специалист, съответно ще коментира. Можеш да се представиш?
Казах Кирил Кимаков и аз съм от старата школа вече 20 години. Съм в .NET екосистемата.
Ами добре, да започнем тогава с теб. Всъщност какво очакваш от .NET и от C# в бъдещите версии?
Това, като тенденция, това, което очаквам, е .NET да заживее истински живот като екосистема за разпределени системи. В смисъл, това, което се случва в Azure, ми дава основание да си мисля, че има бъдеще на истински разпределени системи, микросервизи и прочее неща за .NET. В смисъл, още да се правят микросервизи, още по-лесно е да се правят API endpoints, без да се налагат MVC-та и сложни операции. Това нещо да създаваш разпределени е нещо, което е търпно в очакване. Чакаме с нетърпение Orleans 7. И да, има малко, но пък обещаващи разширения, примерно коментирах за статичните абстрактни методи. Това нещо ще позволи новото поколение се реализация. Очаквам да видим как ще екосистемата, open source екосистемата ще похване нещата.
Чудесно, мерси. Това е наистина едно доста така очаквано, мисля, съзнателно от много хора развитие на платформата. Ради, ти какво мислиш по въпроса?
Какво очаквам? Ами след 7 и от 7?
След 7, да кажем.
Значи за начало по-добри инструменти за разработка. Нещо започвам да виждам как Visual Studio губи аудитория за сметка на конкуренти, като Rider на JetBrains. Аз също имам главоболие, създаден от Visual Studio. Съответно, там борбата е жестока, понеже е много така софтуерна възраст, с тежко минало, с backwards compatibility, с страшно много неща. Сега имам 64 версия, т.е. може да ползвам Visual Studio на Surface-ите си. Нали? Но там очаквам стабилност, повече отколкото фичъри. Перформанс оптимизация и стабилност. Защото не искам да се разправям с Visual Studio, искам да се разправям с кодове. Така че това е едно от нещата. Разбира се, всичко, що е стабилност в .NET. И в компилатора, и в runtime, и в страничните библиотеки. Това са пълни с бъгове. Влезеш в централата на Microsoft, таблото има над 40 000 бъга и така нататък. И съответно стабилност е много важно нещо.
Аз мога да прекъсна само. Преди няколко години, не много, Линус Торвалдс беше казал, има смисъл да компилираме за ARM, само когато нашите машини, на които работим с ARM. И това, че вече има Visual Studio за ARM, може да произвеждаме софтуер, който да се компилира за ARM и да се пусне в облака на ARM. Според мен, нали, прави смисъл, това ще направи платформата по-стабилна. Физъл ще даде положителна насока на това да се развива една ARM екосистема, отколкото просто да си крос-компайлваме.
Плюс има и актуални хардуер на ARM, които стават за девелопмент машини. Да, точно. Да. И така.
Иване, ти?
Ами аз какво очаквам? Всъщност аз го бях подготвил като въпрос, който дискутираме, но ще го кажа като извод, нали? Тъй като продуктите, с които работим, нещата, които правим, са сериозни консуматори на клауд ресурси. Така да се каже, на нашите клиенти и сметките им за Azure ресурсите са огромни. Ако всичките тия перформанси дадат реално изражение в едно намаляване на сметката, крайната в клауда, това би било страхотно и това е нещо, което според мен очаквам да видя в момента при прехода към тази версия.
Аз имам един друг, може би последен такъв въпрос. Как мислите, че е добре да се развие платформата, за да стане по-популярна сред младите хора, които сега има много езици вече, нали, конкуренцията е голяма, излизат нови неща, нови платформи, нови езици.
Дали ние сме правилните хора?
Ами, вие сте стари ползватели.
Аз имам мнение със сигурност. За мен е това, което Microsoft казах 2014-15, ние ще направим нов .NET, един, който работи на всичко и върши работа за всичко. Нали? Лека по лека започва да става истина, защото в момента .NET екосистемата може да правиш всичко на нея. Докато ако си Angular програмист, може да правиш Angular неща в браузъра и там живееш. Нали? Докато си React програмист, плюс-минус на някои други изчадия на технологията, React може да правиш в браузъра и в днешно време, даже днес в един случай, колежка казва, разглеждам Java и обмислям така нататък. И моето първо усещане беше, нали, .NET екосистемата толкова се развива, че можеш с едни познания да правиш всичко. Тоест, в днешно време .NET специалист може да прави web, може да прави UI, може да прави игри. Да, може да прави cloud технология, може да прави какво не още. IoT неща, да. Всякакви неща и наистина .NET 7 постига това нещо. Плюс-минус някакви неща, не може да пишем тестове, може бенчмарк тестове да правим.
Добре.
Blazor има потенциал да върви на Lazy, който е сервер сайт класъм, който е още една ниша, дето.
Да, т.е. с Blazor отваря много такива интересни технологични решения на проблеми.
Аз бих добавил, че точно ние сме хората, които сме отговорни за даването на знанието, интереса към много проблеми. Защото го има този вътрешен бунтарски дух. Не, аз отново, не, аз ще правя нещо друго. И това в много случаи е много пагубно. Виждаме как се появяват стартъпи и умират, само защото са избрали подходящата технология, върху която да стъпят.
Това е много интересно всъщност. Точно неподходяща технология за стартъпи е много добро основание на много хора да им кажа, обърнете внимание на това, което правим от години, защото всяка година излиза нова версия и е все по-добро и по-добро. И са все по-очекивани.
Добре, това са интересни точки за дискусия. Ние се надяваме по-често да имаме такива събития, понеже вече имаме възможност да се събираме и като юзер групи, и като автор ивенти, и по ивенти, и да правим повече панели, където всъщност да дискутираме някакви проблеми. Не просто да имаме passive learning, където определен човек изнася неговото виждане за решаване на някакъв проблем, а можем да имаме и дискусии, които повече хора тези дискусии, някакви добри идеи. Ами, благодаря ви тогава много за участието. Много се радвам, че успяхме да направим това събитие за първи път в новия, обновен, да кажем, офис на Microsoft с втория Dream Space в цялата структура на компанията в света и се надяваме да можем отново, благодарение на хората, които ни съдействаха, като Yochev, благодаря ти, да дойдем тук за някои други събития. И благодаря, които дойдоха и ни гледаха онлайн и мога да ви поканя в събота на JS Talks. За JS имаме други дискусии около JavaScript и web технологиите, но много от казусите са подобни. Така че нека да се видим тогава и да дискутираме. Да, ще има и готини неща, готини подаръци от страна на Microsoft, готини фланелки. Ще има челендж, Cloud Challenge от съответно Microsoft, който ние ще обявиме сега. Този Cloud Challenge е свързан с задача, която се прави с Microsoft Azure, и на 24 ноември ние ще имаме друго събитие по случай релиза на SQL Server 2022 и тогава се надявам пак да се съберем. Ще поканим някои от хората, които са много deep в core SQL нещата. Ще дискутираме тези неща и ще обявим печелившите от Cloud Challenge, който ще анонсираме тази седмица с Microsoft. Благодаря ви още веднъж. Една секунда.